Hello everyone and welcome back to my game development series. This week I programmed the AI for my NPCs. However, before we dive into that, you might have noticed that this video is a bit longer than otherwise, and that is because I will not only talk about what I did, but also how I did it. That also means that I will show some code and I will talk about math, but that's nothing to be afraid of. I'll try to make it as easy as possible. So I basically created two kinds of AIs, a buddy lead system in which the NPC will guide or lead the player towards a specific location, and a buddy follow system in which the NPC will just follow the player around. Let's start with the buddy lead system since that's the easiest. So let me really quickly demonstrate the buddy lead system. The first thing we have to do is walk towards the NPC, and if we get close enough, he'll start leading us towards the target. He'll do that as long as we follow him. However, if we stop right here, the NPC will also stop after the distance has gotten too big. If I then just walk up towards him and the distance gets small enough again, he'll start leading. Now I let him stop one last time, and if I walk off and the distance gets even bigger, he'll come back and return to me. Also, if he can't see me anymore, he'll come and look for me after 5 seconds of invisibility. And I will just start leading again when I follow him. The way this is implemented is with what we programmers call a state machine. So we basically define a bunch of states in an enumeration. For those of you who are not familiar with programming, an enumeration is basically a way to give a name to a bunch of other names. That's the worst explanation I've ever given. Anyways, so there are 5 different states. The waiting state, in which the NPC will wait for the player to catch up. The invisible state, in which the NPC can't see the player, or the other way around. The leading state, in which the NPC will lead the player towards the target. The following state, for the rare occasion where the NPC might got behind the player. And the returning state, in which the player might have gotten too far away, such that we actually want the NPC to also return back to the player. Each of these states is defined in its own function, and as an example we'll take a look at the waiting state. So this is the waiting state's function. It consists of 2 major parts. The transitions, which define when to move from this state to another state, and the behavior, which defines what this state actually does. Let's start with that since that's the shortest thing to talk about. Leader.target is a target location where we want our NPC to walk towards, and leader.transform.position is the current position of our leader. We basically ask the leader to walk to its own position, which is the same as asking to just stand where you are, and that is what the waiting state should do. We then move on to the transitions. The first one is pretty easy. If the follower is not visible, and the exclamation mark means not, so if the follower is not visible, we change the state to the invisible state. That's pretty obvious. The next one is a bit more complicated. If the follower distance is the distance between the player and the NPC, if that gets shorter than the start distance, we'll move into the leading state. So all this is saying is that when the player gets close enough to the NPC should start walking. The last transition rule defines that if the follower distance is bigger than the return distance, we should change the state to returning. The return distance in this case is the maximum distance that the player is allowed to walk away from the NPC before the NPC will return. All the other states also have a function similar to this one, and if you're interested in that, there's a link to the source code for the buddy lead system in the description. The next thing I worked on was the buddy follow system, and I didn't just want a stupid AI where the NPC would just walk straight behind the player, because that just looks stupid, especially since I've got this sewer which has walkways on both sides of the water, and I thought it might be interesting that the player could walk on one side of the walkway and the NPC on the other side. So how does this system work? Well, let's take a look at it. Let's imagine the white dot is the player. The first thing we do is we define some ranges in which the NPC is allowed to stand. For example, the NPC is not allowed to stand inside of this red circle since it is too close to the player. This green distance, on the other hand, is the preferred distance for the NPC to stand at. And then this outer red circle is the maximum distance for the NPC, which means that he is also not allowed to stand outside of it. We then cast a bunch of rays in a circular pattern from the player towards the outer red circle. Casting these rays in a circular pattern is done with this simple piece of code. We start with an angle of 0. We repeat for the amount of rays we want to shoot. We calculate the sine and cosine of the angle. We increase the angle by a fraction of the amount of rays we want to shoot. We then use the sine and cosine we calculated earlier to calculate the direction vector, and then we can use that direction vector to cast these rays. Now, if these rays reach the outer red circle without hitting any obstacle or wall, we snap them back immediately to the green circle, which was the preferred distance for the NPC to walk at. This means that we now found 8 possible positions for the NPC to walk towards, indicated with the blue circles. Now, what if there was a wall? If we shoot a ray in this case, the NPC would not be allowed to stand over there because the white ray terminates within the inner red circle and that was too close to the player. However, if the wall is further away from the player, the white ray ends within a distance that's actually acceptable. However, we will not use the point of impact as a location for the NPC to walk towards, because that would mean he would stand half inside of that wall. So what we do instead is we cast another ray in the normal direction of that wall. For those of you who don't know, a normal is basically a vector that is perpendicular to a surface, and then that location is actually a valid location for the NPC to walk towards. In Unity, I also visualize these 3 distances. We've got the inner red circle in which the NPC isn't allowed to stand. We've got the green circle, which is the preferred distance for the NPC. And we've got the outer red circle, which is the maximum distance for the NPC. If we now enter play mode, you'll also see that the blue target positions get visualized as well. And of course, they update dynamically based on the player's location. Let's now just turn that visualization off and walk for a bit, and if everything goes according to plan, the NPC just follows me around. Which is exactly what happens. Now there's of course one question that remains, and that is which of these possible follow locations should the NPC actually walk towards? We decide that based on a variety of parameters. For example, we want the distance between the player and the NPC to be as close as possible. We also don't want the NPC to be walking in front of the player, and we don't want the NPC to constantly switch between walking on the right and the left side of the player. However, there is still a bug where the NPC isn't quite sure which location to pick. In that case, he really quickly switches between a bunch of locations, as you can see here. Solving that bug shouldn't be that difficult. Especially not since last weekend I went to a local fair where I got this rubber duck. I'll try to explain my problem to my yellow friend, and in the process of doing that I'll probably come up with a solution. Now, since the code for the buddy follow system isn't entirely bug-free, you won't find it in the description. That was all I wanted to say about the buddy AI. Please let me know what you think of these longer, more in-depth videos by using the card up there or by leaving a comment. If you've got any questions or want to become a part of my community, then feel free to join our Discord server. The link will be in the description below. Next week I'll finish a bunch of stuff I already started working on. If you don't want to miss that video, then make sure you subscribe to the channel and hit that bell icon. If you enjoyed this video, then please give it a thumbs up, and I'll see you all next time. Goodbye.